Hello, my name is Danae Mitkas, and I'm a second-year graduate student at the University of Maryland. Together with my professor, Dr. David Lovell, and with Dr. Seth Young from The Ohio State University, we are learning to recognize and stratify flight training activities at general aviation airports using ADS-B data. This research is conducted under the Nextra project on small airport capacity modeling funded by the FAA. Capacity estimation can be more challenging when it comes to small airports. Current capacity models do not take into account small aircraft. Also, capacity estimation depends on reliable data, which are often difficult to find. Small airports may not have air traffic control towers or an automated data collection method, and self-reported data may be questioned. However, this is an important procedure. An airport, given its capacity and its current situation, it can support the need for additional funding. But why focus on flight schools? Training aircraft activity differs from other GA aircraft, and therefore flight schools affect largely their base airport. As expected, students will perform numerous touch and goes to practice on takeoffs and landings. As seen in this graph, a single aircraft performed 12 takeoffs and 12 landings in the course of 1 hour. Also, a training pilot might need more time on the runway to complete an operation. One of the project airports is COSU, which also hosts the Ohio State University Flight School. There, we have installed two ADS-B receivers, one for 978 UAT data and one for 1090 ES data. These are used to create an algorithm which will identify each aircraft activity and then produce operation counts for each airport. These will be used to create an accurate capacity estimation model. However, this is still an ongoing process and we do not have any final results yet. Here we have two images based on the data we've been collecting. On the upper left corner, we have an instant over a real-time map which we have created for our project. Here we can see a busy moment for COSU Airport, where aircraft are landing or taking off, while 3 of them are training aircraft with the OSU call sign. On the lower right corner, we have an image of an aircraft completing multiple touch and goes in the course of 1 hour. As most of you probably already know, when dealing with raw data, the process can be more complicated. Data might be corrupted, inaccurate, or just missing. So we've also worked on finding ways to work with such data. One of the most common problems is the inaccurate altitude. However, we have realized that other information like ground speed or rate of climb is mostly accurate. Therefore, in the cases where the altitude is deemed as unreliable, we have decided to estimate it from the rate of climb. Also, in order to have clean and organized data, all messages received are stored in flights with a unique flight ID to separate each operation, and any messages not related to the airport's activity are discarded. These are some examples of unreliable data. In the first and third case, the altitude is completely incomprehensible. We are not sure why this is happening. However, it might be due to the wrong installation of the transponder. In the cases where we have identified the aircraft with such problem, we have contacted the airport manager to notify the pilot. In the second case, we have a good altitude profile. However, we have this jump from 0 to 900 feet. This is due to the fact that the aircraft is transmitting an altitude equal to 0 while on ground, despite the field elevation, and starts transmitting its actual sea level altitude as soon as it takes off. Our next steps include the finalization of the aircraft activity identification process and to produce results for each airport, such as number of arrivals and departures, runway occupancy time, and other. And then we want to calculate how much a flight school affects an airport's activity. And lastly, use these results to produce an accurate capacity estimation model. Thank you for your attention. We are open to any questions or comments, and you may contact us through email.